Hello, I'm Anthony. Been having great fun wallowing in Reaktor recently. I was just playing with this preset. This is in the Reaktor library, the base subfolder of the Blocks Base Racks directory. It's called Nostalgic Raver, and it's a really nice example of using control voltage processors as distortion units. We'll have a look at that concept today. We're going to deconstruct this preset. I'll show you how it works, but we're really going to kind of look to concentrate on the CVP and the crossfade module next to it. Hope you enjoy this episode today. If you do, check out the Patreon and channel member links below. It's an awesome way to help support my channel, allow me to carry on making this content. Okay, before we go any further, let's just have a listen to the preset. Here it is. So as you can see, I've pressed play in my sequencer there. We're running at 60 BPM, so you're hearing this sequence cycle at that speed. Every time I press a key on the keyboard, we're going to get a different pitch. It's so easy to make Reaktor sound good. I've not done anything. I'm just playing C's, F's and G's. Okay, let's have a look at how the preset hangs together. So we have our clock ticking in the background. It's taking its time from Cubase because it's in external mode, and we're sending that gate into the sequencer. It's generating the 8 notes. All of that stuff is really straightforward. I have done a basic introduction to Reaktor. There's a series that I'll put a link to above and in the description below. If you want to check out the fundamentals of how to build racks in Reaktor, that's a good place to start. So we're going to have a whistle-stop tour through the simpler modules. Okay, so we're sending our pitch instruction out of the sequencer. The oscillator generates tone, sends it into this mixer. And this is the first kind of interesting thing. When I was deconstructing the preset, I thought, oh, what's going on here? Because we've got our audio signal coming into the mixer on channel 1, and you can see that's turned up. But we also have an alternative input coming into input 2, and that's coming from a filter circuit. Now, ultimately, when we get round to the filter circuit, you're going to figure out that this is effectively a bandpass feedback. So the filter circuit, which at this point is the only audio source we have, is sending a bandpassed version of its signal back into the mixer. Now, channel 2 is currently turned down, so you don't hear this. And this is where I love playing with modular systems, in particular deconstructing presets, because you find these little Easter eggs. There's no indication that you're supposed to turn up level 2 on this mixer. You just basically need to figure out how the patch works. But when you do, you get some feedback, bandpass signal, but because it's going back into the mixer, when we feed that back in to the original signal, you're going to get a really nice feedback effect. That resonance really pop. Now, if I turn this up enough, that feedback's going to become basically overwhelming and swamp the sound. You can see we've broken up here. We've exceeded 1. But at around 50%, that's a really nice effect. Nothing to do with control voltage processors, just a nice little treat as we get through that module. So anyway, here's our audio coming out of the mixer, and that's heading into the filter. Now we've got a couple of envelopes here. They're doing very basic duty. The amplifier envelope is opening the VCA, and that's allowing us to hear the sound. Then we have an envelope filter. This output is feeding into input A of our filter unit, and as you can see, that's modulating the cutoff. So these two envelopes, if I get the sequence going again, are going to modulate the filter cutoff and the VCA volume. And you can see both of those envelopes doing their job. All still pretty straightforward stuff. And now we get to the interesting bit, because coming out of the filter, we have 2 outputs. Now there's a load of cables going into and out of this filter, so it's a little bit tricky to see, but basically we have a cable coming into this crossfade module and a second cable going into this control voltage processor module. Let's deal with the input 1 first, the one that's going into input 1 of the crossfade module. If you've never come across a crossfade module before, they're incredibly simple. On the left hand side of the fader, we take our entire signal from input 1. On the right hand side, it's fully input 2, and in the middle, we mix these 2 inputs together. So if I turn this fader all the way to the left, I'm taking my signal exclusively directly from the filter, and we're ignoring this other module we don't have to look at yet. So this is what the filter sounds like, basically unadorned. So that's a pretty straightforward sawtooth being filtered by those couple of modulation sources that we've seen. Very straightforward stuff. Now we get onto the interesting part of the conversation, because this second input coming out of the filter is going into this control voltage processor. And what this thing basically does is manipulates a wave, manipulates a control voltage that's coming into it in one of multiple different ways. In this particular module, this rectification and clipping option here, can you see this shape? Basically, normal mode, if this control voltage processor was going to do no work, it would look like this. So we set our offset to 0 and we draw a diagonal line on this module. In this mode, the control voltage processor is doing exactly the same job as the raw audio that's completely bypassing it. So the left-hand side of this fader, as things stand, is going to sound identical to the right-hand side of the fader. The control voltage processor only starts to do work when you manipulate these controls underneath. Now, we're not dealing with slew today, we don't need to worry about that. The two controls that we are concerned with are the clipping mode and the offset. So I'm going to put the clipping mode back the way it was. What this means is that any control voltage above 0 is chopped off. Let's have a look at what that looks like in the scope. Slow it right down. You can see the top half of the wave being completely clipped. We've basically just described distortion. That's one of the very common means by which you can achieve distortion, simply clipping an arbitrary amount of control voltage off the top of every wave. That's exactly what we've done. What we achieve with the offset knob is that we're able to basically control how much of if we've got like a wave that's this big, then if half of it is being clipped, if we kind of subtract an amount of control voltage from the entire wave, you mitigate the result of half of your signal being lost. You basically manage to retain more of it. If I get the sequence going again, you'll be able to see this really easily. So if I start pulling this offset down, I'm dragging the entire wave or into entirely negative territory. Now, because negative control voltages are unaffected by this control voltage processor, it's only clipping positive control voltages, we get basically more of the wave. So this offset knob is effectively a distortion amount control. And if we turn our offset all the way to fully minimum, now essentially the entire wave is being drawn underneath the 0 line. And there's us clipping it until the point where everything is now above the 0 line, and because everything above 0 is being clipped, we end up with silence. Now in this preset, as it comes out of the box, the offset's somewhere around there. It's certainly negative. That signal is being fed into input 2. We've just been listening to it. That was a fully kind of input 2 laden signal. But that's not how the preset comes out of the box. As designed, this fader is set to 12 o'clock. So you're going to get some of the original signal plus some of the distortion. I'm going to reload this project so that we get back to the preset completely untouched. Okay, I've reloaded my project again. So apart from the fact that I've moved these modules around to make them easier to view, this is the Nostalgic Raver preset exactly out of the box. And now our crossfade distortion module. Labels on modules really help to understand what they're actually doing. This allows us to select a completely undistorted signal. and then introduce distortion. Now, rather than doing that manually, the preset allows us to do it from our modulation wheel. If we have a look at the two outputs coming from the modulation wheel, one of them is coming into input A of our crossfade module, and that's mapped to the fade control. It's not all the way up. So if I set this back to 12 o'clock where it was, if I turn the wheel all the way up, we're nearly getting to maximum, not quite there. We've also got a secondary effect coming out of this modulation wheel. Might as well talk about that too. Input B of the filter is increasing a little bit of resonance, and you can see that peaking up as well. Let's have a listen to those two effects driving from the mod wheel. And obviously you can see the mod wheel in the note in block. And back down again. For the sake of completing the story, let's have a quick look at this macro as well. There's a macro block here with a couple of outputs. Output 1 is coming into the oscilloscope, and it's changing the shape of the wave. Let's have a listen to that. So that's basically turning it into a square wave. And output 2 is seriously messing with the sequencer. You can see we've got direction, steps and offset all being modulated by macro 2. Very nice preset design and an excellent demonstration of CVPs used as distortion units. Hope you enjoyed this one today. Please hit like if you did. Don't forget to subscribe if you haven't already. And I'll see you again. Thanks very much.